All right. So today we're going to hit some of the info on renewable energy. We talked about some of the basics on like the fossil fuels and stuff like that yesterday, and today we're going to hit some of the stuff on renewable energy. We're going to focus kind of on solar, uh, on the solar portion of renewable energy. So we got some a definition here: renewable energy, energy from sources that are constantly being formed, um, or you can also think of it kind of as like renewable energy as sources that can be uh, formed faster than we can use them. Like, in other words, we're not going to run out. So, examples: solar, wind, hydroelectric, geothermal, and biofuels are some examples. Um, what's hydroelectric? Anybody know? Yeah,
Like a dam or water is used to.
yeah, good. It's basically generating electricity from water flow, right? Good. What about geothermal? Do you know what that is?
Heat from the earth.
Yeah, good. Using heat from the earth. Excellent. And then what about biofuels?
Plant matter,
Yeah, and doing what with it?
like burning.
Yeah, well, or creating. It's like using like matter that was once living, right? The bio part, and then creating a fuel out of it that then is used to burn to power things, right? Yeah, good. All right. So solar. Let's take a look at that. Solar is one of the most developed renewable energy sources. It's one of the ones that's kind of been studied and used, and technology advancements have been made along those lines uh, for quite a while now. So, in general, solar as an energy source is used. It occurs by converting electromagnetic rays from the sun into another usable form of energy. So, the sun gives off a whole wide spectrum of rays, right? Like we know that. From come on, trying to find the okay. The electromagnetic spectrum is all electromagnetic waves from like all the way from gamma up to radio kind of type deal. Okay, the sun emits um, a large amount of these spectrums. Like we know the sun gives off visible light. That's easy enough, right? The sun gives off ultraviolet UV. We know that. Talking about you know what causes people to get sunburn, stuff like that. Um, infrared, that's like sort of like heat, but it's not exactly heat, but it's kind of along those lines of like sort of like that. If you know more, like maybe a little more about the sun, you probably know that it also gives off like microwaves and some X-rays. Um, I don't know if it goes all the way. I don't know if it gives off. Does it give off gamma? The sun? I don't know if it does or not, but either way, it gives off a pretty wide spectrum of rays, not just visible light. So um, so uh, solar energy is using the electromagnetic radiation that the sun gives off, um, to using that energy, converting it and using it somehow. I'm going to mark that page so I have it. Okay. So there's a bunch of different ways. The first one that they're listing here is called passive solar heating. It uses the sun's energy to directly heat something. For example, solar energy enters a house through windows and heats the house. Okay. So that would be that's kind of like a direct. You're just using the sun's energy to heat something up. When the sun strikes it, it heats it up. Okay. There's a couple of different versions. They've got solar heating of water. There's something called flat plate collectors. It's a thin, broad box with a glass or a clear plastic top and a black bottom with water tubes embedded within. I was actually going to see it. I don't remember if they have a picture in your book of this or not. Um, hold on, let me see if I know they had some pictures. Yeah, here's a flat plate solar collector. So it's got these like tubes running through it, and then like a black surface in here. Why does it have a black surface? Yeah, black absorbs a very wide range of um, of electromagnetic spectrum, and then it can turn that wide range into heat. And then you've got like tubes that water circulates through, and then it uses that heat that goes through the glass or the plastic, and it traps and turns it into heat, and then that heat is absorbed by the water. So that would be a passive flat plate collector. Okay. In a passive heating system, the collector is lower than the water tank with natural convection currents are used. So, hold on, stuff falling out of my book here. So that's like this. You've got the collector here where it generates heat. And we know what about hot water, just like hot air? It does what in terms of compared to other air?
The warmer waters on top and the cooler water.
Yeah, good. The warmer it is, the less dense it gets, the more it rises, right? So the same thing for the water. So what they do is they actually use that property, and they put um, the the water tank or whatever that they're trying to heat. They put that higher. So then, as you get this passive collector, as the water heats up in here, the hot water will rise and it will travel up and go into the tank. And then any water that gets cold will fall down the tube, and then come through here because it's cold and until as it warms up in here, then it would rise. So it's got like the cycle kind of that goes. It's a convection current. Make sense? All right. So that's passive heating. By passive, it means you like nothing has to be done. Like once you set it up, it just works on its own. Like there's no like parts that have to spin or move or you don't have to plug anything in or anything like that. Like the sun just directly does it with the setup. Okay. Um, Benefits. There's no pollution to it. It can be used in instances where smaller requirements are needed. Little to no maintenance is required. So, can anybody think of a situation where this might be a good solution for like heating water, stuff like that? I know a few of you, I think, said people in here hunt. If you had like a hunting cabin or something, right? Like if you had a hunting, not like a stand, I mean like a hunting cabin on like hunting land or something, right? That's pretty basic, and you're not out there a lot. That might be something like that might be good because it just goes on its own, and you don't have to like use energy or electricity to keep it running or fuel or anything, that kind of stuff. Um, so something like that would be an example of a place that it might be beneficial to use something like that. Okay. On a boat,
Like I'm talking
possibly.
Big, like a boat that somebody might live
Um,
in, like a house.
It could be. The only thing that would be probably a little difficult is because of the setup, you have to have you have to have the collector lower than the tank. So you would have to have the tank because like the collector had to be above board so it could collect sunlight, right? The tank would have to be higher up. Although in a way that might be beneficial because you could have um because then you could have the tank gravity fed to anything else. You know what I mean? Like if you're trying to use the water, and if you do have the tank higher, have a way to get the tank higher up, then any water you use could be gravity fed. So that would be beneficial. Yeah.
People actually do make these for like off-grid use a lot. Like,
Yeah.
there are a lot of TV shows like living off-grid kind of.
Sure.
A lot of you can see a lot of these for hot water.
Mm-hmm.
They can get or to take a hot shower, I guess.
Like generate. Yep. Yeah. Yeah. That's cool. Yeah. And it's good because um, it doesn't require any real, I mean, like very little maintenance or anything like that, or you don't have to have anything plugged in or on running or stuff like that. So now, what would some of the drawbacks? Well, limited heating capability, like you only can heat it as much as like the sunlight you get or whatever, right? The circulation is dependent upon the heat of the water. In cold climates, you would have to integrate heating coils to prevent freezing because the energy generated from the sun wouldn't be enough just to keep it, hot enough to prevent it from freezing. So you would have to have something else with it. But yeah, good. Okay. The second passive one is solar space heating. In solar space heating, the building itself is the collector. Sunlight enters the building through the windows and is converted into heat energy by the objects in the room itself. It can also use collectors similar to those used in the solar heating of water if it's desired. So an example of this is a greenhouse. So a greenhouse, the way a greenhouse works is you've got windows. Now this one is actually on a house itself, this example. But in a greenhouse, or in this example, you've got a bunch of windows, and windows allow the light to enter. When the light strikes other objects, those objects absorb the light, and it converts the energy into heat energy. So like when you go out in the sun and you feel it, like you feel it warm, like you feel you're heating up and your clothes are heating up. The reason is because your body and your clothes and stuff are absorbing some of the different electromagnetic radiation, the light. It's absorbing it, and in absorbing it, that's technically converting it into heat energy. So your clothes, when light is absorbed, it's converted into heat energy then. So what happens is light can get through the glass or the plastic pretty easily. So okay, here's another example. You're like, I'm sure you guys all drive at this point. Your car on a hot sunny day, and you've let it sit outside for a while. You've been at work or something. You get into it, like like sizzles your flesh, like sitting down or something. Why does it get so hot? Like, yeah, we know the sun, but like, why?
There's not really any airflow on it too, so
Literally fake.
Yep. Yeah, no airflow. And what happens is electromagnetic radiation, like the rays from the sun, can travel through the glass without really any problem. Like we know that light and all that stuff passes through glass. What happens is the stuff inside the car absorbs it, converts it to heat energy. Well, guess what? Metal, glass, all that stuff are pretty good insulators against heat. So what happens is the light can enter when it gets converted into heat by the different surfaces and stuff in the vehicle. When it gets converted into thermal energy, that thermal energy cannot escape through the glass and the car, so it gets trapped. Because even though light energy can pass through, heat energy can't pass through easily. So it gets trapped and then it just keeps building up and building up. And that's how a greenhouse works too.
I thought a greenhouse was just like you used to grow plants indoors or something.
Mm-hmm. Yeah. So these aren't greenhouses really. This would be like passive heating of a house, but it works on the same concept. That's why like the purpose of greenhouses is you can yeah, it's indoor, but it's like so you can grow things and during seasons when normally they wouldn't survive outside. Like you can like when it's too cold or whatever, stuff like that. And it's because yeah, the walls like the sides protected, but also it allows the light in, and that heats up inside to provide um, a climate inside to that so it's not cold, so it doesn't so they can survive and thrive and stuff. Yep. Okay. So that would be well, that'd be solar space heating, and everybody's houses have a little bit of that because everybody's houses have windows, so you get a little bit of heating from that. Um, Benefits are very similar: no pollution, little to no setup required, no maintenance, cheap to install and maintain. Drawbacks: dependent upon the amount of daily sun. So backup systems are sometimes required if it's like your main place of where you live and stuff. Like you have to have some kind of backup system that you can rely on if it's not sunny. Limited heating capability. Again, you're limited to just whatever the sun and the objects can turn into heat. Circulation is dependent upon air currents or fans or other appliances. Um, so those would be some of the drawbacks. Okay, questions on those? So that's passive solar heating, where essentially you just have some set up in it and it kind of works on its own and you don't have anything actively converting or changing or anything like that. It just works on the way that energy works and transfers. Then we have active solar heating, which is probably more what you guys are used to thinking about when you think about solar energy. This is when energy from the sun is gathered by collectors and converted into some other usable form of energy. So there's still a wide range of these. Solar heating of water. Solar heating of water for active heating is where heated water is moved by means of a pump. So let me see. I don't know if they have any examples in here. Um, I don't think they have any specific examples in here. But so this is still solar heating, but the heated water is instead of just being by convection currents, you have a pump or something that moves it from one place to another. So again, benefits: no pollution. It's somewhat versatile. In other words, like you can use it in different situations. It's becoming more efficient the more they work on it. Drawbacks: similar to the other passive, cold climates have to integrate heating coils to prevent freezing. There is a maintenance cost associated with active systems because they've got parts that can wear out and break. Okay. So B, solar production of electricity. This is probably the one that you think about when you think about solar energy. Okay. Photovoltaic cells uses solar radiation kinetic energy to cause a transfer of electron between layers of the cell, creating electricity. So these are what you think about with solar panels, okay, or some of these like in here in a calculator. This thing, what that thing is doing with that solar strip on the calculator, well, what that is doing is it's collecting solar energy, light energy, and it's causing a transfer of the electrons between the layers of the cells in this. And then that's electrical energy. So using everything from calculators to homes. Benefits: there's no pollution. Energy can be stored and potentially even sold back to energy companies. The parts don't wear out in terms of like moving parts and stuff. The parts don't really wear out. Now, if you've got like photo cells and stuff, are you just gonna hang out here? You're gonna head back.
I'm probably gonna head back.
Okay. But if stuff is outside, there is maintenance that's associated with like photo cells outside, because they get battered by wind, rain, stuff like that. For in the United States, there's a potential for tax credits for your home installation. You can get um, a lot of times you can get tax credits off if you install solar panels on your home. You can get money off of your house taxes, your home taxes. So drawbacks, again, dependent upon the amount of sun. They can be somewhat complicated to install in houses and homes, and can have a higher installation cost because of that. Because it's not set up to just power directly. You have to actually, and I don't know, I'm trying to remember. Yeah. So, like in your house, if you were to install solar panels, you have to have what's called like a inverter system. So this is an inverter system uh, that connects the photovoltaic cells, the solar panels. It connects them to the electric grid in the house. So you have to have something that like essentially converts the electricity that's generated into um, because okay, yeah, it says it right here. The electricity the electricity that's converted from the solar cells is DC current, direct current, and the electricity that's used in homes is AC or alternating current. So you have to convert it. You have to have an inverter that converts it from direct current to AC current that can be used in your home. So you can't just directly hook the solar panels right into your electrical system and just go at it. You have to have like inverters put in which connects it all. Okay, so that does increase the cost obviously somewhat. So okay, any questions about the solar panel stuff? And they'll actually I know some of my friends that have put solar panels in. A lot of solar companies will come out if they're what's the word I'm looking for? Like not legit, but kind of like legit. If they're if it's a good company and they actually care about doing the right thing like for people, they'll come out and they'll do solar studies before they install them. They'll do solar studies of your house and the land and stuff and make sure that you get enough sunlight over a period of time and to basically to warrant. They'll find the best place to place them and they'll let you know like how much energy you'd be generating and saving so you can calculate to see if it's worth it or not, instead of just coming out and throwing them up and being like, hey, good luck. Like, you know. So like reputable, I guess is the word I'm kind of looking for. Like reputable companies will do solar studies and stuff like that first to kind of give you an idea of the benefit of putting them in. So all right. Concentrated solar power. Sounds like a superhero power. Concentrated solar power. um, or CSP. Uh, so there are different ways to do this as well. Um, and some of them use like photovoltaic cells, some of them use like heated water. So one example is a solar trough, which are long trough-shaped reflectors or concentrators such as mirrors to focus sunlight onto a pipe running down the middle, containing oil or some other heat-absorbing fluid. The fluid is then used in a heat exchanger to boil water and produce steam that drives a generator. So they also give us a picture in our book of this, which is kind of cool. So this, it would be an example of concentrated solar power, these troughs. Um, I know it's a little hard to see, but basically what these are concave mirrors. So it's kind of like a half pipe mirror, and then running down the middle of it are um, are like fluid filled pipes. It's kind of hard to see. I'm trying to. It should be somewhere in there. Mm, hmm. I don't know if they're in each one or if there's like it says there's a central pipe. Um, Sunlight striking is onto a central pipe. I can't tell if it's in the middle of each individual one or if there's a pipe somewhere that they all reflect onto. But either way, there's a pipe somewhere and it reflects onto it and it all heats it up. It's kind of like, the like using a magnifying glass to like fry things or whatever. Like that's kind of what you're doing. You're concentrating all the solar energy on one thing and really heating something up. Um, so uh, there's something called a power tower. It's an array of sun tracking mirrors. So sun tracking mirrors are mirrors that will shift with the sunlight and focus it onto an area, onto a receiver. Pretty sure they had an example. Oh yeah, here you go. Here's a power tower. So in the power tower, you get all the mirrors like concentrating it onto a receiver that's mounted in this. It's a molten salt receiver, and then the hot salt is stored or pumped through a steam generator that drives a kinetic turbo generator. So it's basically almost all of these. Essentially, what they're doing is somehow concentrating sunlight on something that can then absorb that energy and turn it into something that can then usually generate electrical energy somehow. There's just different ways to do it. This is there's a solar dish engine system, which is very similar. You got all the reflectors that uh, it transfers it to an engine that generates electric power. So all very similar versions of solar power. Benefits: no pollution. Energy can be energy can be stored and therefore provide a more consistent source of power. It can be very efficient. The dish engine systems have shown to be up to more than 30% more efficient than other solar energy systems. That's pretty significant when you're talking the large amounts of energy that can be generated. Drawbacks: can only be installed in areas with enough average daily sunlight. So, like, you're not throwing up many solar systems up in the Pacific Northwest, like, Oregon, Washington, where they've got like 364 days a year rains. Like, it's not going to be much good. Um, it can have some possible negative effects on wildlife, particularly birds. There have been instances where, usually they'll adapt, but there have been instances where the concentration of heat from them, if birds fly into the area, can kill them from the concentrated heat from the concentrated rays from it. So, okay, so that's sort of a quick and dirty breakdown of solar power, the different solar power ones. Any questions or comments? So, overall, benefits of solar: very readily available, right? The sun is there constantly. It's just a matter of whether or not, if things are blocking it or not, but the sun's there all the time. It's been fairly well studied, and there's a lot of technology around with it, right? Um, we can convert it into a type of energy that is used, like electrical energy. No pollution, super big benefit. Okay. Drawbacks: a lot of these systems cost money to install and to integrate, um, and it is dependent upon the area if you've got things blocking or not. So yeah,
What's used to build the solar panels?
that's a good question.
Because, like, I know for cars,
Mm-hmm.
like electric cars, like, I've heard that over time they are better for the environment, but like to build one is kind of worse in the beginning compared to like a gas car.
Yeah,
So-
like you have to because like they're made of like force dust mined.
Yeah, like stuff like that.
When it comes to like batteries and all.
Honestly, like, okay, so trying to be objective, there is something to some of that. Like, so like here, if you look, like, there's, so for common, like, solar panels, Okay. Um,
Aluminum. How does that person spell aluminum?
I don't know. I'm not even.
Aluminium.
The technical classification is aluminium,
Yeah.
but like they later said like aluminum is also fine.
I don't like aluminium.
Um,
It's a funky name. I don't even mean it.
so okay. So silicon solar cell materials looks like uh, you've got a monocrystalline layer, a polycrystalline. So mono is single crystalline layer, poly meaning more than one. You got the thin film. So crystalline silicon cells are made of silicon atoms connected to one another in the form of a crystal lattice. So basically silicon. Um, and so okay, so the photovoltaic semiconductors are cadmium telluride. So this is where you're talking about mining some of those metals probably that would have an impact. Copper, indium, gallium, diselenide. So those metals. Um, so I would say trying to be objective. Yes, there is an environmental cost to having to mine some of the metals and having to do those type of things. Um, my feeling from what I've read from different things, what I've read and researched, and my general feeling is um, that there is something to some of that. However, I feel like that's a um, what's the kind of like I don't know if it's a straw man argument or whatever, but it's like it's kind of it's something that people throw out to try to be like, oh well, this isn't as great as you say it is, and like they basically use it as an excuse to not switch over to those type of things and to not go with those type of things. And um, like I said, and it's like a lot of those type of things that there's enough truth in it to give it legs and to give it basis. And I'm not saying we should ignore all of that. Like yeah, we need to look at the environmental impact of the metals we mine and of the stuff that is used to go into it and the processes of making it and any kind of waste from that. But it shouldn't be used as an excuse not to try to improve from what we're using. People use that as an excuse to be like, oh well, it's not that much better for the environment, but like it doesn't take away from the fact that burning fossil fuels are not good for the environment. Like, and so like a lot of other things, as we research more about it and as people study it and as the technology advances, it it gets more efficient and it gets better and it gets cheaper and it gets so. Um, but if you cut it off at the knees and don't even give it a chance, you're never going to get there. Like you know, cars were nowhere close. Like the combustion engines were nowhere close to being as energy efficient as they are today when they first started. And that's because we've had decades and decades of uh, advances and technological advances and work and perfection of them, you know, and they've had decades to try to work on this and make them better. Like they didn't start out like that. And that's the same thing with a lot of the renewable energy. It's not going to start out perfected. It's going to start out, yeah, it's going to be kind of messy and there's going to be expense and there's going to be not as effective and it's going to get, but if you don't jump into that and start working on it, it'll never improve. And all of it comes back to the idea that we really do need more environmentally friendly energy sources than we are currently using, especially as we get more and more people on the planet and more development in undeveloped areas and stuff like that. They're gonna have higher energy requirements. We need um, we need energy that is cleaner and better for the planet and stuff like that. Um, so yeah, that's kind of my take on that. Is that yes, there is truth to some of that, but it should not be used as a oh well, we shouldn't do that. We should just stick with gas and whatever because that shouldn't be used as an excuse to not do it. So, um, but yeah, so
I'm along that line too. Like, I mean, if it's worse, maybe it might be worse to begin with. But I mean, if over time
sure.
we get better, then that's a good.